So we're Savage, one of the cars on our Formula SAE team, and yeah, this is our retrospective presentation. So our project goal was to build and engineering, design, test, all that stuff for a Formula style car. Our competition is June 17th in Lincoln, Nebraska. So our whole year we've been working towards that goal, and we need to also pass technical inspection, which is a really rigorous test to make sure our car is safe for everybody around it and for the driver. And we want to be able to complete all of our events, which are an acceleration run, skid pad, got endurance, and autocross. So 4 events that we aim to pass. What we've done so far is we recently got our car running. So our car is pretty much complete. We're going to play a video of the first time it ran. That's what we've accomplished thus far, and what's left is just to make our car safe to pass technical inspection and safe for the driver, so we don't die. So yeah, so these are 5 of our large differences from the original design. The first one is it occurred our first quarter. What happened was the engine CAD that we used wasn't the right size. We grabbed it on some website, and it was the wrong dimensions, and so we designed our engine bay to the wrong dimensions, and then when we tried to put our engine in, it didn't fit. So we created this red box as an envelope for our engine, and you can see with the engine and the sprocket would be outside of the car. So that put us back a long way, and we had to cut off the whole thing and redo that.
The engine also completely changed. During fall quarter, we actually plan on using a Honda CB400 engine, but it's an engine that's only available in Japan. And so we had it all set up, and we were going to get it imported over to here, and we had a seller and all that, but it ended up being funding that was our biggest problem. And so with our timeline, it didn't correlate. So we ended up having to use the Yamaha R6 engine, which we had used in previous cars.
Also, our suspension has changed because from the engine bay being elongated, we had to change our wheelbase, and then the suspension changes were all different. And we had to change our whole suspension design, and so now it's a little bit not ideal. And also, when we created that, we didn't really account for human error in things like making the chassis, so the rockers were a little bit off, and we had to redo those one more time after that.
And then at the beginning of the year, we were planning on doing a carbon fiber body, and we actually had all the carbon fiber donated to us. We had a facility off campus that was going to help us make the carbon fiber body, and it came down to not having enough money to make the adequate molds for pre-preg using an autoclave. We didn't have the resources to do that, and the school actually did not allow us to go off campus to have somebody else help us, so we ended up going with the aluminum sheet metal body, which is what we currently have. So we're just finishing manufacturing the aluminum one.
Another big difference was the shifting of the car. So we have 6 speeds in our transmission, and we were planning on using some sort of electronic or pneumatic shifting system, but the cheapest one available was about $1,500. Right, so we ended up not going with that, and instead going with the cable shifting system, which cost us about $50. So it's a slower response for the driver, and the driver has to physically move, but it's just a cheaper option. So let's see, design intent. So we also learned it's important to design for all the small details. So like this picture over here, can anyone see what's wrong with this picture?
What is it?
This is our rear rocker. So this tab right here is welded onto the chassis.
Can't move?
The rocker can move, but I'll just tell you. So we can't take that bolt out, right? If you try and take that bolt out, it's going to hit the chassis. So we had to cut that off, or we cut the bolt off and flipped it around. So just small things like that, like while you're manufacturing and designing, we learned the small details are just as important as the big ones.
And we've also learned a lot about organization. As a FSE program this year, we're manufacturing 3 cars, 2 of them from scratch, 1 not. So we have very limited shop space and a lot of resources. We have 3 of everything. So by the time we have all our components in the shop with all the cars, organization is a huge factor, and we've actually lost quite a number of parts between bad communication with teams, losing stuff and having stuff thrown away. So that is one of the biggest parts.
Yeah, and another thing I can't emphasize enough is ask questions, especially if you're not sure. And just things that come down to common sense, like if you're cleaning out a fuel tank, don't put in hand soap that has pumice in it, because it'll completely tear up the fuel pump and all that stuff. So just things like that, ask questions. If you're not sure, talk to the team leads and keep the communication ways open.
And lastly, shop guys are your friends, right? So we've become well acquainted with most of the shop guys, like Steve Hag and stuff like that. They help us out a lot. Steve mainly just, if he likes us, will make our life a lot easier. And if he doesn't trust you, then it's a lot more difficult to get things done. And I mean, now we have access to the weld shop, we have access to the sheet metal shop. So he helps us out a lot. Also Ted, who is in charge of the machine shop, has been helping us just straight up make things for free. Because it's like, if you guys need help, and I'm not doing that much right now, just mill something up for us in like 10 minutes, where it would take us maybe 2 hours to make. So becoming friends with the guys who are really experienced in this kind of thing, they're also very helpful.
And what we hope to do for the future is, like a lot of our problems have been, is funding. We really want to work on getting better sponsorships and more funding. This year we started looking for sponsorships in winter quarter, when in reality we should be looking in August, September, stuff like that. That way, if we talk to the company, we're first on their waiting list. That way you get better stuff, more funding. So we really need to work on getting more money for our program.
We also hope to have better accountability and documentation, especially during the design process. So right now with our sub-teams, we can just kind of hand out different tasks for people without too much accountability. Most of it's just like verbal. So I think what we would like to do is have like a big task list and assign people and have like certain dates and certain like people double checking everything in the design process.
Design freezes would also be very helpful, because as you guys know, as engineers, you'll continuously iterate something to try to make it better. However, if there's not a specific date that says, by this date you need to start manufacturing, regardless of where you are in your design, you're going to run into a lot of problems in the future when you go to test it and not have enough time to fix the component. So leaving enough time for testing and then making another iteration after you've measured the performance of it through testing is really, really a key thing.
And lastly, this has been a hope for a while, and we're not sure how far off in the future it is or whether or not it's feasible, but we'd like to change the class system a little bit, because these are design units that everybody needs. So we get a lot of people who sign up and say, oh, we'll put in 3 units worth and we'll get our hours done and then we'll leave, even if they're in the middle of some sort of design or in the middle of making something. And that leaves us in a bad spot, because then we have a half-finished part or a half-finished design and people just disappear. It also goes into the accountability thing. But yeah, that's just a hope. I'm not sure how feasible it is. And that's it. Is that question?
Questions?
I have a question about